Welcome to the next lecture. In this lecture, we will study the cellular system, cellular system design, which forms the base of mobile communication systems. You might previously we were dealing with the concept of modulation. So the concept of modulation is related to a single transmitter and single receiver. But in mobile communications, we have several hundreds of users within one area who have their mobile equipment they want to communicate, and how to handle large number of users. So one of the basic concept in cellular systems, and one of the fundamental concept in cellular systems, is something called frequency reuse. To motivate for this frequency reuse, let's make some points. Suppose you have a single, so here's a simple problem. So we have large number of people having this mobile equipment with them, and they want to communicate with each other around the world. Definitely they cannot communicate directly, right? Okay, if you are in the same adjoining area, maybe then it's okay. But you have a small handheld device, you cannot bump in too much power into the antenna of this small device. So definitely point to point communication from one mobile to other mobile is not possible. Now what is done is, you have something called base station, a very big base station. And what every mobile communicates with the base station, and base station then communicates with other mobile. Suppose you dial some number, so that signal goes to base station, and base station will then communicate to will broadcast a message to all the mobiles, that whoever has this number, you have a call. Suppose it is the number of this mobile, and it will, you will communicate to base station, base station communicate to this mobile. This is how we are connected. Now here the fundamental problem is of now multiple users will communicate, right? So definitely you have to use different frequencies if they communicate simultaneously. Now if this is one area served by this base station, there will be another area here served by this base station, and you have limited frequency. If you give different frequency to every area, to every user, then there will be scarcity of the frequency. So now what is done is, something called frequency reuse is done. Let me introduce the concept in a very simple way. Suppose here is area designated by A, and I will put this hexagon around it. What is this hexagon? Suppose you have a base station, there is an antenna connect at the top of the base station. Now this antenna will have some particular region where the signal of this antenna is having significant strength, and outside this region the signal of this antenna will be very weak. So we call this as the coverage area for this antenna. Okay, now what will be the shape of the coverage region? Okay, so ideally if it is an omnidirectional antenna, it should have been circle. But when we represent things on paper for our analysis, circles have this issue that if you draw multiple circles, there will be an area left, right, which does not so I can say this antenna is a, this is antenna B, this is antenna C. Antenna A serves this area, so it means that in this area the significant strength is of this antenna signal. Antenna B signal will have very weak strength here. Similarly, antenna B serves this area, antenna C serves this area, but there is in this part which is not being served by any of the three antennas. That is the issue with circular shape. Then I want a shape which should cover the whole area, so I have one option, this rectangle, right? Other option, I have triangle, I can have these triangles. Okay, equilateral triangle, of course, or square. But what I want is, and this is called cell. This one area served by a base station is called cell. That is the reason for the name cellular system. But the issue is that I want this cell should serve the weakest mobiles within the area, and weakest mobiles. By weakest, I mean that the mobiles which get the least signal, they are straight at the edge. Suppose if you have antenna here, then the weakest signal will be at these edges, right? Now, for a given distance between center of the polygon and its perimeter points, hexagon has the largest area of the three. And if by using hexagonal shape for the cell, we will need fewer number of cells, and which can cover the geographical area, whole geographical area. Suppose if you see one hexagon, right, like this, if I have antenna here, now if I needed a triangular, then I would need several triangles, right? So this is one triangle, another triangle, another triangle. So 1 2 3 4 5 6. So then I would have needed 6 cells if I would represent with a triangular region, right? So 6 cells of triangles are equivalent to 1 cell of hexagon. So that is why theoretically we represent the area covered by one base station by an hexagon. Okay, so that is why I have drawn here hexagon. Now suppose here is the base station A, and this hexagon is the coverage area for that base station, and then this is B. Okay, I'm bad at drawing here right now, and this is C. Okay, now suppose you allocate some maybe some 50 frequencies to base station A. It's an example. As an example, in GSM you have 900 megahertz to some, say, suppose you have 950 megahertz available. So in this range you can give any frequencies. Suppose out of this you give 50 different frequencies to A. What does that mean? That at a time 50 people can call. Okay, they can communicate with the base station. They will be allocated 50 different frequencies. Then since base station B is nearer to A, you cannot use these 50 frequencies. Why? Although the signal of A will be weaker after this boundary, because now from this boundary onwards the signal coming from the base station B will be stronger than that of A, but still the signal of base station A will reach to this point. So if you use same frequency, there will be interference. Suppose a person in this cell calls and he is given a frequency 910 megahertz. At the same time, if person here also calls and base station B allocates 910 megahertz frequency to this guy, what will happen is that this guy may receive some part of this signal. Since it is of the same frequency, there will be interference. Same thing will happen to this person also. So what is done? The adjacent cells should have definitely different frequencies. But what we can do easily is, I will designate this cell again with A. Since this cell is farther from this cell, okay, this cell A is farther away from this cell A, I can use same frequency here. So now if a person is calling at this point and a person is calling at this point at the same time, and suppose both of them are given the same frequency 910 megahertz, but the signal of this A, the person here, will not reach to this point easily. It will be very weak because they are farther away. Similarly, I can now designate this as B, because again this is farther away, right? And I can call this as C, right? and you see this one I can call B, and this one I can call A. So in this way we are seeing that we are reusing the frequency. So wherever I write A, all the A's means that all these base stations will use the same frequency. Since they are farther away, so there will be less interference. But suppose if you feel that okay, although I have reused, I have kept them a little bit far away, but still there is an interference which is not good. So what you can do, we can do something like this. So we can increase the reuse, we can say, pattern. That means here is this A, so this is one base station, and then there is another base station B, another base station here C, another base station here D, another base station here E, another base station here F, and another base station here G. A, B, C, D, E, F, G, they all use different frequencies. Okay. Now what will I do is I will now reuse the frequency. Just a minute. Yeah. I'll just increase it. Yeah, no, it's okay. Now I should do it in such a way that the two cells using the same frequency should be farther away. It means that although no one can stop me putting here suppose C, but more than C, I see that B is farther away. I could have put here F also, I could have put here A also, but I will put here B. Why? Because B is this B, I will mark with red color, this B and this B, they are farther away, right? As compared to if I put here C or F or A, right? They are quite near. Now this is B, and now I can basically from this onwards I can directly repeat the above scenario. So below B there is A, below A there is E, right? And then here is D, here is C, here is G, here is F. Okay, now you see this E is farther away from this E. Now all the same alphabets means that all those cells will use the same frequency. Similarly you can let me use another color to highlight this one. So this is one, we call it cluster also. I am drawing with blue. What does that mean? Okay, so this one blue, these 7 cells, they use the same, they use different frequencies, all of them. Now I will use red color for the second cluster. Okay, so all these cells reuse the frequencies of previous cluster. We can I can draw one more here. So this I can call as B, then C, D, A, E, F, G. Oh, okay, so this is B. Okay, so it starts from this C. Okay, so same way you can repeat this pattern. Suppose here is an example. Suppose each base station A or whatever uses 50 different frequencies, right? So 7 cells will use 350 different frequencies. That is it. We don't need more than 350 because we will then repeat it everywhere. As an example, suppose NIT has a tower. It uses some, maybe nowadays we use a lot of frequencies. Suppose it uses 500 different frequencies because there are a lot of people, who have mobiles there. Then the another area may be Hazratbal. So NIT and Hazratbal tower, the Dargah Hazratbal shrine, there is a tower. Suppose they will use different frequencies because they are nearer to each other. But if we move further towards, suppose, or those of you who reside near NIT, you were in NIT for more than 3 years, so you know a lot of areas. Suppose nearest one area is Foreshore Road, where we go to Nishat. So from that, suppose when you reach Nishat, you can use you can use same frequencies as NIT because the signal from NIT will not now easily reach to the Nishat area. That is what the concept of frequency reuse is. So in next lecture we will quantify the various quantities related to this frequency reuse, and we will also define something called system capacity. We'll do some computations, some calculations, so that we easily get how many cells we can pack together, okay, and what are the different frequencies we can give, and what will be the overall system capacity also.